This question really resonated with me because I think one of the most referred to Matplotlib question on Stack Overflow, or maybe not the most, but at least the top 10, always has to do with legends. Legends are one of the most convenient thing to make in Matplotlib, and oftentimes you'll just see, oh, how do I draw a legend? Oh, ax.legend, no arguments, no nothing. Matplotlib just knows. And when you draw this, you think, oh, wait, does it just know? Is this my legend right here in the top right, this little empty box? Well, maybe it doesn't know everything. Maybe we need to tell it just a little bit of, well, how do I draw this? And so we'll see here that when you want to use the convenience method that is ax.legend, you actually have to give it this label parameter. You have to not give the legend the label parameter, but you have to associate a given artist that you're putting on the screen with some type of named representation of that artist. Matplotlib will iterate across all of the lines, it'll iterate across all of the patches, it'll iterate across all, not the text, but all of the primitives that are attached to it that are actually used to draw something meaningful on the axes. And it'll find those, and it'll pull the artist out, and it'll pull that corresponding label, and then that is when you get your free legend. And so when you think about these things, Matplotlib has a lot of convenience, but what if I want to make a legend that almost has nothing to do with my data? What if I want to just have full control over these things? In order to make your own legend, you can still use the ax.legend method call, but you need to supply now your own labels and your own handles. Handles are just how Matplotlib refers to artists in terms of the legend. Handles are specific. You can take any artist, any patch, or any line. I could take a circle and feed them in here, and I'll essentially be creating my own custom legend. You can see there in the top right, I have a patch corresponding to label 1. I have a line corresponding to label 2. Matplotlib does some transformations under the hood to convert a given artist into that little representation of that artist. And so when you think here, I'm not just taking that same patch and making it smaller. I'm making a new patch, shrinking it down, doing some other transformations to it such that I can represent it in a meaningful way in my legend without making it the same size as my entire plot. And so that's what the legend handle map does for us, but we don't really need to think about those unless you want to create your own custom legend key or legend entry. You can work with this idea of labels and handles in order to create your own custom legends. Now there are figure legends, just like there's an axes legend. If you say, I want to put my legend outside of my axes, yeah, you can do that with the call to ax.legend, but you can also do that very conveniently in a figure.legend. The difference here is the coordinate system that we're using to place the legend. With a figure legend, we are using the coordinate system of the figure. With the axes legend, we're using the 0 to 1 that spans the axes. So if we wanted to put an axes legend outside of it, we would have to give it a location or a B-box whose lower left corner, whichever corner we decide to plot from, is outside of that axis, so greater than 1. But you can see here with figure.legend, we can just use the convenience specifier of right, and it'll put it in the center right of the entire figure for us. We bring that set of axes, the grid that we're drawing on, in just a little bit so the legend isn't overlapping with our axes here. Now we can use this idea and we can actually create some very powerful legends, some very powerful layout. And if I want to draw, let's say, multiple axes, and I'll show you what this looks like. It's just a bunch of trigonometric functions multiplied by some coefficient here. So sine and cosine times 1, sine and cosine times 2, sine and cosine times 3, just to change the frequency of this wave. Wait a minute. What's blue and what's orange? Oh, right, I need my legend. Since I have 3 plots here that all overlap with the color system, I want to draw them in a way on my figure such that they're all represented. Oh man, but we see the figure actually loops over every single artist and all of its children. So we're looping over each set of axes, we're getting all the artists from those axes, and then we end up with a legend that's repeated a bunch. Well, maybe I just want the axes.legend. So let's give me the ax.legend. This will correspond to my last set of axes. And when I do this, I see, okay, now my legend's just showing up on the bottom plot. I guess my other options, I could plot the legend with every single plot, or I know what to do. I can use bbox to anchor to move this legend around. That's not perfect, right? I put it at 1, 1. But as I mentioned earlier, I can actually put this above my axes, so maybe 1, 2 will give me what I want. And I've lifted it up just a little bit higher. Maybe I need to put it just maybe at 1.4. Oh, now you can see I'm off the screen now, so maybe 1.1 might give us what we want. And if you've ever done this kind of fiddling in Matplotlib, you know how tiring it is to regenerate your plot, look at it, and be like, I need to move it just over a little bit. I need to move it just up a little bit. And what you really need to be thinking of is your transform system here. I can say, give me just a legend from my last axes. I could do this on any axis, or any set of axes, and it'll work. But instead of plotting on your axes coordinate system, plot on my figure coordinate system. You can see here, just by specifying 1 and 0.5, which means plot it all the way to the right and plot it halfway up the figure, I can make a very nice centered legend that is aesthetically pleasing, easy to look at, and ready to send to your boss for those good brownie points.